Hello, this is the third video in the second vector series for OCR AS Core Pure Further Mathematics. We will look at the Cartesian form of a line in 3D. Sometimes a vector may be given in Cartesian form in either 2D or 3D. As you can see here, lambda equals x minus a1 over d1 equals y minus a2 over d2 is the 2D form, and the formula below gives lambda in 3 dimensionals. The Cartesian form is not always easy to work with, and so the first step in a problem may be to convert the Cartesian form into vector form. To convert the vector equation given into the form ax plus by equals c, in other words the Cartesian form, we would look first at the vector form r equals 1 minus 3 plus lambda 2, 5. This is obviously a two-dimensional line. One way of doing this is to write that x equals 1 plus 2 lambda and rearrange to get lambda equals x minus 1 over 2. In a similar manner, y equals minus 3 plus 5 lambda, rearranging to get lambda equals y plus 3 over 5. Now if we equate these, we find the Cartesian form x minus 1 over 2 equals y plus 3 over 5. We can then rearrange this into the more familiar form 5x minus 2y equals 11. If we will continue to try and put it into the y equals mx plus c form that you may be more familiar with as the equation of a straight line, then you would get that y equals 5 over 2x minus 11 over 2. And then you will notice that m equals 5 over 2, or in other words, d2 over d1 from the vector equation. To convert between vector and Cartesian forms in 2 dimensions, we start with the vector equation r equals a plus lambda d, which if you remember can be written in component form a1, a2, and vector direction d, d1, d2. We would find that lambda equaled x minus a1 all over d1 equal to y minus a2 all over d2. Rearranging this, we can see that if you want it then in the format y equals mx plus c, the gradient m would be d2 over d1. Working in 3 dimensions, and again starting from the vector equation in the form r equals a plus lambda d, where we split a and d down into the a1, a2, a3 and d1, d2, d3 components, we can then write that x equals a1 plus lambda d1, y equals a2 plus lambda d2, and z would equal a3 plus lambda d3. Rearranging each equation to make lambda the subject, we then get the Cartesian form x minus a1 over d1 equals y minus a2 over d2 equals z minus a3 over d3. All of these, of course, equal lambda. You should either pause now or later on to research on integral or from your textbook how these forms are written when any of the elements from the direction vector, i.e. d1, d2 or d3, are 0, bearing in mind that of course you cannot divide by 0. Here's an example finding the Cartesian form of a vector line given, remembering that a, to get onto the line, is 2, 0, minus 3, and that the direction b is the 1, 4, minus 2 vector. So x will equal 2 plus lambda, leading to lambda equals x minus 2. Y just equals 4 lambda, so that also then equals y over 4, and z will equal minus 3 minus 2 lambda. So in this case lambda equals z plus 3 all over minus 2. could say that it was x minus 2 divided by 1 if we wish to. This then is the Cartesian form, where the equals lambda at the end is optional. If we want to go back the other way and find the vector form of the Cartesian line as given, then we know from this that 2 lambda will equal x minus 1, and that therefore x must equal 2 lambda plus 1. We also know that minus 4 lambda equals y plus 2, rearranging to y equals minus 2 minus 4 lambda, and that z equals 3 lambda. This is because each of those fractions equaled lambda. In which case, that leads us to r equals 1 minus 2 and 0 plus lambda 2 minus 4 and 3. You may wish to pause the video here and check all the working for yourselves. Here is another example for you to think about later. You may wish to pause and decide on an approach at this stage. We're trying to find the equation of a line through 2 points in Cartesian form. As a hint, you will remember that we were able to do this in vector form and had an example in previous series. So a hint might well be to work out the vector equation first and then convert it to the Cartesian form. Remembering that you're trying to avoid a direction vector with 0 elements, or take that into account carefully. Here is a possible vector equation and the associated Cartesian form, if you wish to check against it later. In the next session, we will look at the intersection of lines in 2 dimensions.